Hello, very good evening, guys. Good evening. Welcome to BYJU'S exam prep. Very good evening, all of you. I hope everyone is good. Let me check from my end. I think all good. Good evening. Good evening. All right. So today we're gonna practice some good level of questions. That is the gate level questions from the subject of theory of machine. So quickly buckle up, guys, because now it's time to practice some questions, and I'll be giving you some question as an homework also. राइट तो जल्दी से ज्वाइन करिए और बताइए कोई ऑडियो और वीडियो पे इफ यू आर हैविंग डाउट और डिफिकल्टी, कोई प्रॉब्लम है, टेक्निकल प्रॉब्लम है, यू कैन डू टेल मी द कमेंट सेक्शन. हेलो, गुड इवनिंग, गुड इवनिंग. लेट मी चेक फ्रॉम माय एंड. आई थिंक ऑल गुड. All right, all right. One second, guys, one second. Okay, so shall we begin with the practice session? Yes. All good. Okay. So as you know that theory of machine is a subject which actually carries a weightage of like 7 to 9 marks. So it is classified as the A category subject. So I want you guys to please be actively participating for today's session. Okay. So I think all good. Yeah. Right. So 500 plus question. This is the rank up series. Audio और video कोई दिक्कत है तो यार जल्दी से comment section में बता सकते हैं, or else we can start off this today's session. All right, chaliye. So before starting the session, I hope so everyone has connected with me on the Telegram channel that I am showing on the screen. अगर नहीं किया तो जल्दी से कर लीजिए. Okay, fine. One second, guys. Good evening, good evening. जब छींक आने वाली होती है तब नहीं आती ना, तो it's like very something like I was about to sneeze, but suddenly the sneeze went back. Okay, so you can connect with me on my Telegram channel, that is Mechanical by Suraj, where I have always been actively participating for your practice session. So do join this, and I'll be sharing all the links. PDF also will be shared of this session, and the last session also will also being shared, right? And as you know that ESE mains का सब result is out, तो वही mock test चल रहा है. You can register yourself. अभी तक नहीं किया तो कर सकते हैं. सो नाउ वी आर टॉकिंग अबाउट द थ्योरी ऑफ मशीन. द सेकंड पार्ट, फर्स्ट पार्ट नहीं हो पाया था ड्यू टू सम टेक्निकल इश्यूज, है ना. तो विल बी सॉल्विंग एंटायर सिलेबस क्वेश्चन फ्रॉम टुडेज session, and tomorrow then we'll be having production engineering on 14 and 15. I'll be taking engineering mechanics. The same timing is 5 p.m. Okay, fine. So जिन्होंने अभी तक those, because in our app there are lot many classes going on, so you can download the app from this link which is there in every video. At the bottom there will be a link in front of my name, something like this. So you can click on that and you can download the app, because there are a lot many free sessions. If I talk about my personal sessions, I have started mechanics practice session for gate examination from today onwards. So today we'll be having your mechanics for equilibrium condition. Then tomorrow we'll be having friction and its application, kinetics of rigid bodies, and thrust. This is all the session we are having, the free classes, the free app sessions on our app. ओके, सो यू नीड टू एक्टिवली पार्टिसिपेट. और इसके लिए आपको करना क्या है, आपको एग्जैक्टली 8 o'clock ज्वाइन करना है, और you will be getting the link of this session also on my Telegram channel, which I have already shared on the screen. और जिन्होंने ऐप डाउनलोड नहीं किया है, you can download your BYJU'S exam prep app from this link which is there at the bottom of the any video. कोई भी वीडियो खोलेंगे, at the bottom will be having this link will be given. Okay, चलो. So let's begin with the first question on the screen. Let us see. It's a question from your vibration. Good evening, Mani. Good evening. A U-tube as shown in the figure contains a liquid of density rho. The liquid is set into motion by applying a force. What is the natural frequency of vibration? Omega n की value पूछा है. What is the value of natural frequency of vibration for a U-tube manometer? Let us see. Who will be giving me the answer? U-tube manometer के लिए it is containing a fluid which is having a density, or liquid have a density of rho. If you are giving some initial deflection, then what will be the natural frequency? Because obvious बात है, this is the level, है ना. Fine, Pascal's law के हिसाब से we will be having same level. If you are trying to apply some amount of force, the liquid level will be increasing, and if you release that force, so this liquid will be moving up and down. So you have to tell me what is the natural frequency of oscillation for this kind of arrangement. Okay, Option A, under root G by L. Option B, under root of G by 2L. Option C, root 2G by L. Or option D, 3G by 2L. Root of that. कैसे करेंगे? Apply the simple concept. बिल्कुल basic concept से चलना है. You won't be having any issue. Go for Newton's approach, or you can go for D'Alembert approach from the initial deflection. Okay. Money is going with option B. और कोई जल्दी से बताइए. What is the next question? What is the answer for this? Everyone. A, B, C or D. Solve करें. देखो, simple सा question है. If you are applying some amount of force, this is the initial position, right? If you apply some amount of force, the liquid will be moving downward, है ना? And this side the liquid will be moving upward. ऐसे होगा, right? If I try to draw this diagram over here, ये आपका वो YouTube manometer है ना? Bear with me with that diagram. This is the initial position. Akshay is also going with option B. So let us suppose you are applying some force on the fluid. तो fluid आपका almost same diameter है ना? Same diameter. So can we say whatever downward deflection will be happening, the same deflection will be happening at the top, right? Acha, tell me one thing. Can we say this fluid will be responsible for the backward motion of the or we can say the restoring force will be created by this weight of this particular fluid, है ना? Can we say जो आपका इस level से ऊपर उठा है this particular fluid, that will be responsible for your restoring torque. So can we say that is equal to mx double dot is equal to minus of restoring force, or I can say plus your rho into a into 2x, है ना? Fine. Rho into a into 2x, that is equal to 0. Can we say like this? जितना liquid ऊपर आया है, height is 2x, area is a, that is the total volume. Volume into density and into g. Volume into density will be mass, right? And multiplied by the acceleration due to gravity, this will be the force that will be having the return motion, the restoring force responsible for the backward motion, right? बस solve कर दीजिए. You try to solve it, that's it. So I can write it, this mass is equal to rho into a, the total length is L, the total length is equal to L, right, into x double dot plus rho into a into 2x into g is equal to 0. Rho a get cancelled out, so we are having x double dot plus 2g by L into x equal to 0. Yes, आ गया simplified equation. Rho a will be cancelling out, only will be left out with 2g x by L, and we know that x double dot plus omega n square x is equal to 0. Comparing these two equation, omega n will be equal to under root of 2g by L, और हमारे पास ये option कौन सा है? Option C is the correct answer. Option C is the correct answer. Is this clear? Akshay, Mani, clear हुआ? Option B is not correct. थोड़ा सा उल्टा कर दिया. I think now you are able to understand. Option C is the correct answer. Okay, clear? I told you I'll be taking some good level of questions जिसमें आपका practice के साथ साथ concept clarity will be happening. Okay, it's not a routine practice, it's a standard question that we'll be practicing for gate level, right? Question number 1 done. Anyone having any doubt in this, please do let me know. And I'll be giving you some question as an homework also, तो उसको भी solve कीजिएगा, but उससे पहले we'll be solving some questions on the live session. चलिए, question number 2 on the screen. This is a question from the Hartnell governor. A Hartnell governor, as shown in the figure, the maximum and the minimum speed of rotation are 23 radian per second and 22 radian per second respectively. The maximum radius of rotation is twice the minimum radius. That means let us suppose maximum radius is 2. So R2 is equal to twice of R1. Right. So you have to tell me what will be the ratio of B by A. B is this dimension, A is this dimension. You have to tell me what's the ratio of this. How to proceed? Is there any formulation जहां से we can calculate this ratio of B by A? Yes. Akshay, Mani, any formulation जहां से we can calculate? देखो, what is happening is this is a Hartnell governor, so this spring control governor ऐसे होता है आपका. This is the mass, this is your bell crank lever, will be having pivot over here, है ना, and will be having a sleeve connected over here. There's a sleeve, okay, and we'll be having a spring over here, right? Similarly, we'll be having some same arrangement over here, okay, right? Now what is happening is there are two radii of rotation. आपको radius of rotation का वो भी दे रखा relation RT is equal to twice of R1, and they have given you the omega 1 and omega 2, है ना? Omega 1 is equal to your 22 radian per second, and omega 2 is equal to 23 radian per second. So can we calculate the centrifugal force acting on the mass? निकाल सकते हैं mr omega square, है ना? So we can say F1 is equal to mr1 omega 1 square. So this is m into r1. Mass is given, I think, 3 kg. Mass is given as 3 kg. So 3 into r1 into omega 1 value is 22 square. Can you tell me what's the value in terms of r1? You'll be getting this value in terms of r1. And F2 is equal to m into r2 into omega 2 square. So 3 into r2 into omega is 23 का होल स्क्वायर. कितना है बताइए? into 3 1452 R1 Newton, and this one will be equal to 1587. Yes, we are getting this formulation, this value, and we know that the stiffness of the spring is equal to twice of A by B into F2 minus F1 divided by R2 minus R1. We know this formulation. बस we know the value of K, है ना? K वैल्यू आपको दे रखा है 4 न्यूटन पर mm. A by B वहां से निकल जाएगा. F2 और F1 R1 R2 के बीच में है, and we know that there's a relation between R2 and R1 that is equal to twice of R. So place all these given conditions in our this particular formulation and get the final value. Units का ध्यान रखिए, please make sure you are using the appropriate units. Units अगर सही नहीं रखेंगे, then you will be getting the wrong answer, and then wrong value will be available in the option. Okay. Now stiffness is 4 Newton per mm, so that will be equal to 4000 Newton per meter. So this is equal to 4000 Newton per meter. That is equal to 2 into A by B. F2 is equal to 1587 R2 minus 1452 R1 divided by R2 minus R1. Yes. Okay. We can place the value of R2 is equal to twice of R1. तो यहाँ place करते हैं. So we can say 4000 is equal to twice of A by B whole square. है ना? Whole square. Right? It's whole square. हाँ, whole square होता है ना? Whole square. F2 is 1587 into twice of R1 minus 1452 R1 divided by 2 R1 minus R1. Right? Solve it and tell me what is the value of B by A. B by A की value बताइए. B by A की value बताइए quickly. What is the value of B by A? So 1587 into 2 minus 1452 into 2 divided by 4000. Are you getting 0.927? 0.928? 0.928? Basically 0.9279, but we are getting 0.928. 3 decibel तक round off कर लिया. Right? So we are getting 0.928 and 0.928, that is option D. Option D is the correct answer. Clear है? Governor देखो, if I see the recent 3 years, governors say they have started asking. Before that they were not asked a single question from governors, but recent 2 years में या 3 years में they have asked the question. One was from the what governor, one was from the characteristics of governor, that is your controlling force versus radius for a spring control. Unstable, stable and isochronous. उसमें से क्वेश्चन पूछा था. 0.92. Very good Shreyas, very good Mani. Clear? Akshay, done. Question number 2. Clear है? Question बड़ा easy था, but only thing you have to do is you need to apply simple logic. चलिए next question number 3 on the screen. For a flywheel, omega max by omega minimum is equal to 1.5. Then the value of coefficient of speed of fluctuation in percentage, they are asking you in percentage, what is the value of CS? Simple question, 1 marks question. They are given you omega max by omega minimum value. Then what is the value of CS? What is coefficient fluctuation of speed? CS is equal to range by mean. Range by mean, है ना? चलिए, what is the range value? Omega max minus omega minimum by omega max plus omega minimum by 2, right? Okay, take omega minimum common, so we can say 2 into omega max by omega minimum minus 1 divided by omega max by omega minimum plus 1. But solve कीजिए and tell me what's the answer. This you have to place it. You just need to place the value. So you'll be getting 2 into 1.5 minus 1 divided by 1.5 plus 1, right? So this is 2 into 0.5 by 2.5. So what is the value you are getting? 0.4, है ना? Are you getting 0.4? Yes. 0.4, but they are asking the value in percentage. So into 100 करेंगे, this is 40%. Answer is 40. Answer is 40 because they are asking the value in percentage. So make sure अगर आप 0.4 रखेंगे, then you will be getting the wrong answer. मतलब आपको correct answer का marks नहीं मिलेगा. NAT है specific. NAT पे you have to make sure in which units they are asking. बहुत बार ये गलती करते हैं. Specifically percentage में ऐसा गलती होता है. Many number of times this kind of mistakes is being repeatedly happening with many of the students. And second kind of mistakes is they are not converting the units. ठीक है, units conversion is very important, especially in NAT, because in MCQ you are actually seeing the options, तो उसमें chances of mistakes are slightly less. ठीक है, but NAT में because we don't know the option, तो हो सकता है यहाँ पे गलती हो. ठीक है, चलिए question number 4 on the screen. Two bodies A and B of equal mass are suspended from two separate massless springs of spring constant K and 2K. Respectively, if the body oscillate vertically such that their maximum velocities are equal, then what is the ratio of amplitude of A by B? What is the ratio of amplitude of A by B? This is they are asking you. How to proceed? But they have given one condition that the maximum velocities are equal. Maximum velocities are equal. 0.5. Okay, there one answer is 0.5. Anyone else? Money is going with option. One is going with 0.5. Anyone else who can tell me? Achha, tell me one thing. What would be the value of omega and for both the case? Let's say this is case A, and this is case number B, right? Case A and case B having same masses, it is being attached with the same mass. So you have to tell me what's the value of omega. And sir, for case number A, omega n for A will be equal to under root of K by M. Omega n for B is equal to under root of 2K by M. We know this formulation, right? And we know that the maximum velocities are same. So VA maximum will be equal to A into omega NA, and VB maximum is equal to the amplitude into this one, right? And because both are same, so let us equate these two. So amplitude of A into omega NA is equal to amplitude of B into omega NB, right? Okay, fine. So they are asking you A by B. So amplitude of A by amplitude of B is equal to omega NB by omega NA, right? B is equal to 2K by M. So this is root of 2, that is equal to 1.414. So answer is 1.414. 1.414 is the correct answer. Yes, A by B पूछा है ना? What is omega and B? That is root 2K by M. है ना? We can write like this. This is also equal to root 2 of omega NA, or omega NB by omega NA is equal to root 2. So same value we have placed it over here. That is equal to root 2. And I'm getting this to be 0.141 is the final correct answer. Clear? 0.5 या 0.707 is not at all correct. So make sure, ये बहुत ही common mistake करते हैं in a hurry. हाँ वही बोला नहीं, बहुत ही common mistakes हैं that you are responding. 0.5 तो चलो blunder था, but 0.707 was a common mistake. They are taking the opposite of that. AB by AA, that will be getting 0.707, which is not correct because they are asking you the ratio amplitude of A by B. Okay. चलिए next question number 5th on the screen. Can we proceed? चलिए next question again from a governor topic, I think. Yeah, what governor? A what governor is shown in the figure if the speed of the governor changes from n1 to n2, that is from 61 rpm, 60 to 61 rpm. What is the change in governor height? What is the lift value? Lift, that is h1 minus h2, that they are asking. Simple question. It's a what governor, and in what governor we are having only one formulation, that is equal to h is equal to 895 by n square. है ना? For what governor your h is equal to 895 by n square. है ना? ये हमें पता है, right? चलिए solve it and tell me what is the answer. Solve it and tell me what is the correct answer. Question easy है, but only thing you have to do is थोड़ा सा effort डालिए. So we can say that h1 is equal to 895 by n1 square, h2 is equal to 895 by n2 square, right? So h1 minus h2, that is equal to 895 by 1 upon 60 ka square minus 1 upon 61 ka square. Solve it. What is the, and you have to tell me the value in mm. आपका आंसर मीटर में आएगा, देन यू हैव टू कन्वर्ट द वैल्यू इन mm. कितना रहा है? सॉल्व करो. 61 स्क्वायर माइनस 60 स्क्वायर, 61 स्क्वायर इंटू 60 स्क्वायर. Yes, are we getting 8.08 into 10 to the power minus 3 meter? So this is equal to 8.08 mm. Okay, fine. 1 meter, इतना राउंड ऑफ नहीं करना. Do not round off till that value. बहुत ज्यादा राउंड ऑफ कर दिया आपने. 8.08 mm is the final correct answer. This is the height of governor that we are talking about. Clear है? Understood? Is this clear? Done. 8.08 mm. 1 meter कहां से आ गया? Clear? Done. Question number 5th. Okay. All right. Very good, Akshay. Very good. 8.08 mm. Perfect. Perfect. चलिए next question. Next question is very important. Question number 6th. Try this question. A vibration system consists of a mass of 150 kg, 3 springs and a damper of damping coefficient 8 Newton centimeter per centimeter second is being given. So they have given the value of C is equal to 8 Newton centimeter per second, and the value of mass is equal to 150 kg. Right? 3 springs are connected, each spring having a stiffness of 900 Newton per centimeter. Then you have to tell me a damper with a damping coefficient of this is being given. Okay. अच्छा, it is being written 2 times. मैंने वही सोचा कि ये 2 बार क्यों लिखा है ना? अब ठीक है. Then what is the natural frequency of damped vibration? Omega d value. Omega d value you need to respond. You need to tell me the omega d value. Quickly. What is the value of omega d? यूनिट गलत लिखा. हाँ, अब सही है. न्यूटन सेकंड पर सेंटीमीटर होता है ना. अब ठीक. What is the value of omega d? So first of all tell me what will be the effective stiffness of the spring? There are three springs connected, two in parallel, one with the series. Let us say this is K1, this is K2, and this is K3. So can we say that if three springs are connected like this is K1, K2, K3. So I can say K equivalent will be equal to, this will be added. So K1 plus K2 into K3 divided by K1 plus K2 into K plus K3. Yes? Okay. So all are having the same value, that is 900. So this is 900 square into 900, 600 Newton per centimeter. Akshay, very good. Hai 600%. Now we can calculate all the rest values. So omega n, what is the value of omega n? Omega is equal to under root of K equivalent by m. है ना, mass given है आपको 150 kg. So omega n is equal to, this is 600 by 150. Is there any other additional value that we need to write? Omega n 2 है पक्का? Sure. Is omega n 2 or any other value? भाई यहाँ पे यूनिट देखो ना, the K value is given in Newton per centimeter. You have to convert this into meter. You have to convert this into meters. This is root of 400. That is 20 radian per second. 20 radian per second. This is the value of omega n. Please make sure units की गलती मत करें. I'm seeing many times students are repeatedly doing the same mistake. Okay. Omega n is this one. Now zeta value we need to calculate. Zeta is equal to C by 2 m omega n. C वैल्यू देखो, C की वैल्यू यूनिट क्या है, दैट इज 8 न्यूटन पर सेंटीमीटर. इसको मीटर में कन्वर्ट करना है, इसको भी वी हैव टू कन्वर्ट दिस इनटू मीटर. ओके फाइन, तो करिए. सो दिस इज 8 per centimeter, so this will be 8 into 100 divided by 2 into 150 into 20. What's the value of zeta you're getting? Yes, 20 you are getting. Very good. This is omega n, but we have to calculate the value of omega d, है ना. तो ऑप्शन देखो, इसमें ये नहीं हो सकता, ये नहीं हो सकता, between A and C, because omega d is always less than that of omega n. ये हमेशा याद रखिएगा, omega d is always that of omega n, है ना. चलिए, so from here I can get the value of zeta is equal to 800 divided by 2 into 150 into 220, that is equal to 0.133. Yes, 0.133. Chalo, we got the value of zeta, we got the value of omega, and so omega d will be equal to under root of 1 minus zeta square into omega n, है ना. So we can calculate this. Omega d is equal to under root of 1 minus 0.133 whole square into 20. कितना आ रहा है? Very good Akshay, very good. Whole square, 1 minus answer under root of this into 20. 19.8, 19.82 radian per second. 19.82 radian per second. So we are getting option A as a correct answer. Okay, option A as the correct answer. Done. मनी आज क्या हुआ, बहुत ही ज्यादा सिली मिस्टेक कर रहे हो आज. आई थिंक यू आर डूइंग वेरी सिली मिस्टेक टुडे, एंड वट एवर सिली मिस्टेक यू आर डूइंग ना, दैट सेम सिली मिस्टेक्स wrong option will be there in the examination. ये होगा, right? If whatever small mistakes you are doing now, the same answer, the same incorrect answer will be available in the option. So make sure you're not falling into that trap. थोड़ा सा time ले लीजिए, but try to solve questions accurately. Okay, so option A is the correct answer. Exactly, we're getting 19.82 radian per second. This is the damped frequency of vibration. All right, chaliye next question, question number 7. This is a 1 marks question from the concept of degree of freedom. फॉर्मूला याद नहीं है यार, ये तो हमने इतनी बार प्रैक्टिस कर लिया है. ऐसे वाले अगर आपने अटेंड किया था प्रैक्टिस सेशन ऑफ द थ्योरी ऑफ मशीन, उसमें तो करीबन हमने 4 to 5 क्वेश्चंस वर फ्रॉम दिस टॉपिक ओनली. परसों ही किया था शायद, कल परसों में, परसों किया था. हाँ चलिए, कैलकुलेट द डिग्री ऑफ फ्रीडम. मोबिलिटी मीन्स डिग्री ऑफ फ्रीडम. मोबिलिटी मीन्स डिग्री ऑफ फ्रीडम. चलिए 1 मार्क्स क्वेश्चन है. Is it a superstructure, structure, a kinematic chain, or an unconstrained chain? A, B, C, or D? This is a ternary link. This is a single link. Okay, this is not a this one. This is a ternary link. Make sure you are taking. This is a ternary link. Single link है ये. तो वो shaded था actually. It was not visible. उन्होंने इनको black and white कर दिया. Okay, ternary link. What is the degree of freedom? F is equal to A, B, C, or D. Okay, very good, Akshay. Option C, absolutely correct. Absolutely correct. It's a kinematic chain. चलो count करते number of links. 1, 2, 3, 4, 5, 6, 7, and 1. है ना? Number of links is equal to 7. Number of binary joint, this is a binary joint, this is a binary joint, this is a binary joint, binary joint, binary joint, binary joint, binary joint, binary joint, and higher pair. Higher pair. So number of binary joint or lower pair is equal to 1, 2, 3, 4, 5, 6, 7, 8. 8. H is equal to 1. There is no redundant value. So now we can see Krusebeck equation F is equal to 3 n minus 1 minus 2j minus h. So 3 into n value is 7 minus 1 minus 2 into 8 minus 1. So this is 12 minus 18. 18 minus 16 minus 1, that is equal to 1. This is a kinematic chain. This is a kinematic chain. Okay, fine. Option C is the correct answer. Very good. Option C is correct. Clear hai? Done. Next question chale. Okay, let's proceed for the next question. Question number 8 on the screen. Easy one. A gear train is shown in the figure. If the pinion transmit 250 kilowatt, power is given 250 kilowatt. Okay, RPM is given. अच्छा, opinion का है n1, इसको मैं 1 ले लेता हूँ, इसको 2 ले, तो n1 is equal to 1800 rpm. Tangential load F is equal to 2.1048 kilonewton. What is the value of gear ratio? Gear ratio they are asking. Some central distance being given. No number of teeth. Number of teeth नहीं दे रखा, अगर दे रखा होता तो it would have been very easy. चलिए ट्राई कीजिए. Question is interesting. Question is interesting. They have given you power, they have given you the tangential load on the gear tooth, and definitely tangential load will be the same for both the keys. That is FT. This is your FT, tangential load. Chaliye, what will be the answer to this question? कैसे करें? देखो, power is equal to tau into omega and there is no losses being given, so can we say whatever power be generated, the same power be generated at the output, that is gear number 2, है ना? So we can say P is equal to torque into omega 1. तो torque निकाल लेते पहले. Power is 250, this is 250, torque that is into 2 pi, and n value is 1800 by 60. Can you tell me what's the value of torque in kilonewton meter? What's the value of torque in kilonewton meter? Anyone? 2 pi into 1800. So 1.326. 1.326. Right? This is the torque value. बहुत बढ़िया. There's one more formulation. The torque is being created due to this force, है ना? जो torque हो रहा है and it is basically creating this force. So can we say tau 1 is equal to Ft into R1? Ft into R1, है ना? So from here, can we get the value of R1? Tau 1 is equal to 1.326 divided by Ft. Ft is 22.2 22.101048. So tell me what is the value you're getting. This will be in meter. आप mm में convert कर सकते हैं क्योंकि they are given the value central distance. So 1.326 divided by 22.1048. This is coming out to be this one. So 1, 1, 2, 3. So we are getting 59.98 mm. 60 mm, round off to, we can say 60 mm. Yes, are we getting 60 mm? Hana? Yes. Now, if we got the value of this as 60 mm, there's some central distance being given. So, can we say what is the value of R2? Dekho, this is R1, this is R2. So, can we say R1 plus R2 is equal to 660. So, R2 will be equal to 660 minus R1. R1 we are just going to calculate, that is equal to 60. So, this is equal to 600 mm. Fine. So, we got the value of R1, we got the value of R2. R1 is equal to 60 mm and R2 is equal to 600 mm. Then what is the value of gear ratio? Sir, gear ratio is equal to number of teeth on the gear to the number of teeth on the pinion, or I can say the diameter of the gear to the diameter of the pinion, or I can say the radius of gear to the radius of pinion. That is equal to 600 by 60, that is 10. So we are getting the value to be 10 and option B is the correct answer. Option B is the correct answer. So this is not a direct straightforward, right? इसमें थोड़ा सा घुमा के क्वेश्चन पूछा है. So I think that is the reason I told you this is an important question. Clear है? Option B, 10 is the gear ratio, right? Done. Okay, normally normally इस टाइप के क्वेश्चन में आपको मॉड्यूल गिवन होता है. They are giving the module and from there you are calculating the rest of the parameters. But here they are not given the value of module. So definitely you need to approach by this way and then only you will be able to get the correct answer. Okay, चलो question number 9 on the screen. हाँ, easy one. Torque method लगाइए, easy होगा. Whenever a roller is rolling not about center, about an offset point, अगर आपका spring लगा है, then go for this one, torque method. A disc of radius r and mass m, ठीक है, radius r and mass m is connected to two springs having equal stiffness. If disc rolls without slipping, then what is the natural frequency of vibration? हाँ, correct. मॉड्यूल वाला तो easy हो जाता है आपका. Central distance equal to m by 2 d1 plus or t1 plus t2, है ना? m by 2 t1 plus t2, वहां से आपका क्वेश्चन सॉल्व हो जाता है. चलिए, try this one. Which of the following is giving us the correct formulation of the natural frequency of vibration? Correct money, correct. अब next question पे चलते हैं. Next question number 9 on the screen. Quickly, और उसके बाद आपको homework questions भी करने हैं at home and the solution for the same I'll be providing you. But before that, solution तभी मिलेगा जब तक आप अपना question मेरे को solve करके नहीं देंगे, because some students are not solving and getting the solution without solving is not appropriate. पहले solve करो, गलती करो, then I'll be giving you the medicine. है ना? बीमार होने से पहले मेडिसिन खाओगे तो रिएक्शन हो जाएगा. पहले बीमार हो तभी तो मेडिसिन खाना है. ऑप्शन सी. ओके, अक्षय इज गोइंग विद ऑप्शन सी. चलिए, लेट्स ट्राई टू सॉल्व इट नाउ. Because this is a pure rolling, so entire body is rotating about this point. Let's say this is point B. This is point B. So if I say from this point there is a small deflection of theta, small deflection of theta. Okay, so let's say this is x. So can we say x is equal to a plus r into theta approximately? Can we say this deflection in the spring will be equal to a plus r into theta? और जितना डिफ्लेक्शन होगा उतना फोर्स लगेगा. Here the spring is being compressed, it will be having an opposite restoring torque that is equal to k into a plus r into theta into a plus r, right? And because this spring is being elongated, it will be trying to create a restoring torque in this direction, having the same magnitude as that of this one. Same hoga. That is equal to K into A plus R whole square into theta. These are the restoring torque. There is no other force. So I can say IB theta double dot plus K into A plus R whole square theta plus K into A plus R whole square theta equal to 0. So from here I can say theta B into theta double dot plus 2K A plus R whole square theta equal to 0. Now what is the mass moment of inertia of a disc rotating about at the point of contact? mr square by 2 तो O पे होता है ना? So the moment of inertia at point B is equal to mr square by 2 plus mr square, that is equal to 3 mr square by 2. That's it. Place it over here. Place it over here, है ना? So we'll be getting this to be IB theta double dot plus 2K A plus capital R whole square into theta equal to 0. So this is 3 by 2 m into r square theta double dot plus 2K A plus R whole square theta equal to 0. So rearranging the equation, we can say theta double dot plus 4K by 3m A plus R whole square divided by r square equal to 0. Okay? So now we can compare this equation with our standard format. So we know that theta double dot plus omega n square theta equal to 0. Comparing these two equations, we can say omega n is equal to A plus R by capital R under root of 4K by 3m. Yes? Are we getting this? A plus capital R divided by capital R 4K by 3m. So R plus capital R. So option C is the correct answer. Okay. Oh no, this one nahi. Option D is the correct answer. 4K by 3m है ना? Option D. Option D is the correct answer. R plus A. Right. Done. Clear hai? Understood? Done? Anyone having any doubt? Okay. Option D, R plus A divided by capital R under root of 4K by 3m. Option C कैसा आ रहा था आप लोगों का? Some students were going with option C also. I think option C is correct अगर वो 2 बाहर होगा root के. If that 2 is outside the root, then answer C is correct. 2R plus A divided by R under root of K by 3m, that will be the correct answer. Chali, question number 10th on the screen. So before going to question number 10, this Sunday we'll be having the National Scholarship Test, and along with that, Dheeraj will be coming up live on 18th October for all the GATE 2025 aspirants. चलिए next question पे चलते हैं. Question number 10th on the screen. The turbine rotor of a ship has a mass of 8 ton. The radius of gyration is 0.6 meter. हाँ ये लीजिए, ये रहा ना अक्षय. कहीं डाउट तो पूछिए. If you're having any doubt at any point, please tell me in the comment section. कोई दिक्कत नहीं है. All clear? हमने कुछ नहीं किया, हमने बस रिस्टोरिंग टॉर्क निकाला है एट दिस पॉइंट बिकॉज एक्स कंप्रेशन होगा. सो के इंटू एक्स इंटू ए प्लस आर. नॉर्मली ये क्या होगा? के इंटू एक्स इंटू ए प्लस आर. दिस इज द टॉर्क बीइंग अप्लाइड. एक्स कितना है? ए आर इंटू थीटा. तो बस मैंने वही तो प्लेस किया है ओवर हियर. वही चीज मैंने यहाँ प्लेस किया है ओवर हियर. ओके, देयर आर टू रिस्टोरिंग टॉर्क्स, राइट? सो दैट इज द फॉर्मुलेशन दैट वी हैव केप्ट. उसको रिजॉल्व किया, उसको सॉल्व किया, एंड देन वी आर गेटिंग दिस वन. ठीक है, डन. क्लियर अक्षय? अक्षय, ओके, अक्षय नहीं, अक्षय. डन. चलिए नेक्स्ट क्वेश्चन करें अब. ऑल क्लियर? चलिए नेक्स्ट क्वेश्चन ऑन द स्क्रीन फ्रॉम द गायरोस्कोप. A turbine rotor mass is given as mass is equal to 8000 kg, right? Radius of gyration is equal to 0.6 meter. RPM is equal to 1800 RPM, right? That is equal to omega is equal to 2 pi 1800 by 60. So this is coming out to be 30, that is 60 pi radian per second. Okay. The ship travels with a velocity of 100 kilometer per hour. So this will be equal to 100 into 1000 divided by 3600 meter per second, right? So this is equal to, this get cancelled out, this is 1000 by 36 meter per second. And taking a turn of 75 meters, so from here, can I say the angular velocity of precision, omega p, we can calculate. So omega p is equal to V by R. V is 1000 by 36 divided by 75. This much of radian per second is the value, right? So now we can place, they are saying that what is the gyroscopic couple. So C is equal to I omega omega p. I कितना है 8000 into k square mk square. I is equal to mk square. Okay, k value is 0.6 into omega p is 60 pi, and omega p is 1000 divided by 36 into 75. Okay, solve it and tell me what is the nearest value that we are getting. Option A, B, C or D, and that too they are asking in kilo. So I think that is much more easier to calculate now. 0.6 square into 60 pi divided by 36 into 75. So are we getting 201, 201, somewhere around 201.06 kilo Newton meter. 201, 69.3, pakka? Is there any option 69.3? Nahi. So 201, that is nearest option is option A. देख लीजिए what is the value, because they are talking about kilonewton, so it will be having into 10 to the power minus 3, this 1000 will be cancelling out. So from there we are getting 201, approximately 200 भी बोल सकते हैं. That's the correct answer. Okay, चलो चलो ठीक है, very good, clear है. देखो units का conversion देख लीजिएगा, because students again I'm constantly in every session I do point out, क्योंकि if you are doing that silly mistake of not unit conversion, तो जो wrong value आएगी ना यार वो होगा option में, that will surely will be available in the option. So do not commit this conversion वाला mistake, because ये बहुत ही ज़्यादा problematic है. चलो next question. In a vibrating system, if actual damping coefficient is 40 Newton meter per second, so C is equal to 40 Newton second per meter, and critical damping coefficient is equal to 420 Newton second per meter, then what is the value of logarithmic decrement? Very easy question. ऐसे question कितने कर लिए हमने? We have solved a lot many questions like this. Logarithmic decrement value they are asking. तो zeta निकालते हैं. What's the value of zeta? Zeta is equal to C by CC. 40 by 420, that is equal to 1 by 7, है ना? Zeta is equal to 1 by 7, right? Oh, no, okay, fine. 1 by 7 नहीं, 2 by 21, 2 by 21, 2 by 21, 1 by 7, I was taking 6 value, मैं 60 by 420 कर रहा था बार बार. Okay, 2 by 21, right? So this is nearest value is 0.095. Okay, 0.095. चलिए, so we know that delta is equal to, हाँ, very good, 2 pi zeta divided by under root of 1 minus zeta square. बस place करना है. 2 pi into 0.095 divided by under root of 1 minus 0.095 square. कितना है आंसर? C. Everyone is getting option C. 0.6. Very good. 0.5, 0.57 कुछ आ रहा है. 0.58 something. So we can round off to 0.6. Option C is the correct answer. Option C is the correct answer. Near about 59 आ रहा है. एक बार check कर लेते हैं. 0.095. 1 minus 0.095 square. 0.599. 0.599 आ रहा है तो 0.6 द करेक्ट आंसर. ओके, 0.599 is the value, so we can round off to 1. ठीक है, चलो क्वेश्चन नंबर 12 ऑन द स्क्रीन. अच्छा चलो, ये हमारे थे क्वेश्चंस प्रैक्टिस सेशन. नाउ फ्रॉम क्वेश्चन नंबर 12 onwards there are some home task problem which you have to solve at home, right? अच्छे खासे क्वेश्चंस हैं फॉर यू गाइस. वन क्वेश्चन फ्रॉम फ्लाईव्हील, मल्टी सिलेंडर फ्लाईव्हील क्वेश्चन, बहुत इजी है. स्केल को कन्वर्ट करना मत भूलेगा. यू कैन कैलकुलेट द डेल्टा ई निकाल लीजिए, मैक्सिमम फ्लक्चुएशन, राइट, एंड दैट विल बी ऑल्सो इक्वल टू आई ओमेगा स्क्वायर सी एस. वहां से यू कैन कैलकुलेट द वैल्यू ऑफ आई, मोमेंट ऑफ इनर्शिया, राइट. 13th question, very easy. You have to calculate the mu minimum to mu maximum. Mu minimum to mu maximum. This question is saying this is the value of mu. Okay. Next question is very easy. You can calculate omega 1 by omega 2. Very easy. They have given some combination of springs. For 15th question, they are asking you what is the velocity of the block at this point. Velocity of the block at this point. You can calculate that. 16 is a very interesting and easy question from velocity analysis. 17 is also from velocity analysis. हाँ हाँ बिल्कुल, ये मैं भी PDF डाउनलोड कर दूंगा. You can download from there also. Okay, fine. And there's a mock test being planned by our team. So you have to ratio yourself from 14 to 20th October के बीच में, right? So now it will be live by between 14 to 20. तो 14 से पहले register कर लीजिए. So if at about 14th को we'll be having that subject test of aptitude, mathematics and thermodynamics and heat transfer. Subject test 2 from 28th of October, right? We'll be having fluid mechanics, your strength of material, power plant. ठीक है, this is basically the free mock test. Free all India mock test, जिसमें क्या होता है, the students from any part of the country, they can go and attempt this mock test where you'll be having, this is the complete schedule. I hope so that you are able to see. आपको एक बार ये hide भी कर देता हूँ, right? So this is the schedule that we are having. 14, 28, इसमें आपके subjects के नाम भी लिखे हुए हैं. When you download this PDF ना, this particular schedule will be available. आप एक काम कीजिएगा, you download this PDF. I'll be sharing this on my Telegram channel, on this particular Telegram channel over here. ठीक है, मैं एक बार यहाँ पे शेयर कर दूंगा. मैकेनिकल MCHA मैकेनिकल बाय सूरज गोपी, वहाँ पे I'll be sharing this all this PDF, so you can download and you can save this for your reference कि किस दिन कौन सा mock test होगा. And full length mock test, there are like 4 full length mock tests being planned. Okay, from 16th of December we'll be having full length plan. For 16th, then 30th December, then 13th January and 27th January, free all India mock test is being provided. Okay, clear, right? So this is all by for today's session. तो एक बार ये फिर से मैं repeat कर रहा हूँ, मैकेनिकल बाय सूरज आप ये कर सकते हैं, मैकेनिकल बाय सूरज गोपी. ओके, आप टेलीग्राम में सर्च कर सकते हैं, वहां पे I'll be sharing this PDF right now. Fine, चलिए. So thank you guys for joining with me. I hope you all enjoyed. तो मिलते हैं हम लोग अब ऐप वाली क्लासेस में, जहाँ पे we'll be practicing starting mechanics के practice question. Today's topic is equilibrium. Tomorrow will be your trusses. Simultaneously we'll be having the complete set of questions being practiced for GATE examination. ठीक है, fine. So this is it from my side. So let's meet tomorrow. कल हम लोग मिलेंगे on YouTube at 6:30, है ना. Tomorrow we'll be meeting at 6:30, right? और उसमें हम लोग प्रैक्टिस करेंगे I think mechanics, engineering mechanics, the previous year question from 2020 to 2023. 4 साल के question be practicing. So do join tomorrow at 6:30 on our YouTube channel and please do subscribe. Like नहीं किया है like तो please कर लीजिए. Tomorrow meeting in the same place. Time will be 6:30. Okay, thank you, bye bye, take care, stay safe, enjoy your day with BYJU'S exam prep. Thank you all of you.